This is the third mini lecture for section 5.1. We're going to talk about the other two representations we have yet to discuss. We won't say as much about them though, because in later sections we'll go into more detail on them. It'll be a little bit easier to understand the properties once we've learned how to add and subtract. Okay, so the next representation the book uses is what's called mail-time representations. I don't know what exactly the origin of mail time is, but we'll just stick with the language the book uses. It's a little bit awkward. The basic idea is that checks are positive, bills are negative. And so, if you, at mail time, if you get a check in the mail, that makes your net worth go up. If you get a bill, that means you owe someone else money, your net worth goes down. So, at mail time, if you're delivered a bill for $39, what happens to your net worth? That should be net. The answer is that it goes down $39. If you get a bill for $39, then you just lost $39. So that question and the answer both represent the integer negative 39. Or again, at mail time, you're delivered a check for $18. Are you richer or poorer, and by how much? The answer is that you're richer by $18. You just got $18 in the mail. So the problem and that answer represent the integer positive 18. So think of this as basically the same as the bank account illustration I was using earlier. The checks are black, the bills are red. Checks make your money go up, bills make your money go down. Remember, by the way, that when you get a bill in the mail, your net worth goes down because the company, maybe it's the electric company, they're saying that you owe them money. Okay, the thing that you send the company is not a bill. I know everyone says that. You say, I'm sending in my bills, or I'm writing my bills. Okay, what you're actually sending is a check. Or, something amounting to that. You're sending them money. But you don't send them a bill. They send you a bill. So if you're working at a company and you send a customer a bill, that means that you're getting money. So we'll talk about that a bit in the next section. Don't overcomplicate it. Just remember, checks are positive, they make your money go up. Bills are negative and they make your money go down when you get them. Okay, so like I said, we'll come back to that in the next section. The third representation in this section is number line representations. So integers can be represented by points on the number line or by arrows. Okay, so typically, we would draw a number line that points in both directions. 0 is in the middle, maybe. You have the positive integers on the right. Negative integers on the left. So these points represent the integers, but you can also represent integers by arrows, and the arrows can be located anywhere. For example, the number 4 could be represented by drawing an arrow pointing from -5 to -1. Okay, so it points from left to right 4 units. Okay, so we can represent the number 4 as that point on the number line or as an arrow. Okay, let's see. The number -3 we could represent as an arrow pointing from right to left 3 units. So for instance, from 5 to 2, let's say. Okay, so -3 can be represented by that, or it could be represented by the point on the line. Okay, the arrow, it could be anywhere. It just needs to point 3 units to the left. Then the number 0, of course, also could be anywhere. It's represented by an arrow that just points back to where it started. Or, of course, you've got that number 0 in the middle of the number line. Okay, so if you have an integer represented by a point, then its sign is represented by which side of 0 it's on, and its magnitude is the distance from 0. So for instance, -3, that's 3 units away from 0. So its magnitude, its absolute value, is 3. And remember, if in case you've forgotten this from grade school, when you write little bars around a number, that means that you want the absolute value. Okay, so that's 3. When I was an undergraduate, I was trying to get a job as a math tutor, and I had an interview for it. I took a little test, and I did okay in the test. But then the lady who was doing the hiring, or my supervisor, she said, well, before I hire you as a tutor, I have one question I want to ask you. What is the absolute value of a number? Explain it to me. And I explained to her what I thought, and unfortunately I got it wrong. I still got the job, but she had to explain it to me. So I said the absolute value of a number just makes the number positive. And she said no, that's not what it does. What it does is it tells you the distance from 0. So it's like, when I'm talking about money, your bank account. If I look at an entry on there and I ignore whether it's a deposit or a withdrawal, and I just look at the dollar amount, that piece of information is like the absolute value. So these little bars mean forget which side of 0 it's on, just tell me how big it is. Okay, and that's the absolute value or the magnitude. Okay, in higher level math like algebra, you can talk about how it just makes it positive. There's no real harm in that, but that's not how it's defined. Okay, now on the other hand, if you're representing an integer with an arrow, the length of the arrow is the magnitude, and the direction it points tells you the sign. So if it points to the right, it's positive. If it points to the left, it's negative. The length is the absolute value or the magnitude. So for instance, this -3 arrow, it's 3 units long, so the magnitude is 3. And we'll come back to number line representations once we talk about addition and subtraction. Okay, so here's the exercises. They're fairly straightforward. Please try to get them done, and we'll talk about them the next time we meet.